All right. Hopefully this video will work. So I'm gonna record 2 labs per videos, and I'm going to upload them in an extra module I will create so it doesn't generate any confusions. And I'm doing that because the labs are not very long, especially because you're gonna be given the data. All right, for the first lab, you do have to do a few, you do have to perform a few calculations, but a lot of the measurements that you are supposed to do in the lab are going to be given to you. However, it's good that you understand what the aim of the lab is, which is basically to understand the difference between using different tools to perform measurements, such as a ruler, a Vernier caliper, and a micrometer. So you're going to be introduced, some of you are going to be introduced for the first time to the international system. So here is what you have to complete by examining a metric site of a meter stick. You have to complete how many meters, decimeters, centimeters, and millimeters are in 1 meter stick. All right, which basically looks like this. All right, yep. So if you take a look at this, there's a meter stick. So you can Google one, and then you can take a look at the divisions, right? You have, for example, here 32, 33 centimeters, and then you have 10 divisions in between. So that's how you find the millimeters, all right, or what a millimeter is. So that's the first part of the procedure. Then you're going to be introduced to the idea of uncertainties, all right, and discrepancies. So one of the goals of this lab is to understand what you need to do or what values you need to read if you are using a Vernier caliper and a micrometer. Now, to learn a little bit more about how to use a micrometer and a Vernier caliper, I will strongly suggest that you open these documents that you can find in the module for lab 1. So the first lab is instruments and measurements. And you have the document I was showing you here, all in blank. And here you can find the data. So if you go there, you can find the instructions, the introduction, the equipment, the dimensional requirements, the procedure, when I actually went over already, and then what's the meaning of these readings that you're going to be using. Now, the first section of the lab is asking you to measure the length, the width, and the height of a small block with an inexpensive ruler. So I did that for you guys because I'm not going to assume that you guys have access to a block. However, feel free to do it yourself and write down the measurements here. If you don't have access to that, then you can go to measurement lab data, and then you can find this table fill in. Now, I'm giving you the first, the second, and the third measurement for each of these measurements, the length, the width, and the height. The only thing you have to do is you have to find the average. And you find the average by adding all these values and dividing them by 3, which is the amount of values you have. So once you have that, you are completing this step of the lab. All right? Here is where you use the Vernier caliper. The difference between the Vernier caliper and the inexpensive ruler lies on the amount of significant figures. So let's suppose you are using the Vernier caliper to measure the length, the width, or the height of the block. The Vernier caliper looks like that. And you have a couple of scales that you need to worry about. You have the main scale and the caliper scale. That's where it gives you the extra significant figure. All right. Of course, for a ruler, the uncertainty for a ruler is 0.5 centimeters. For a caliper, it's different. right? For a caliper, you will have two significant figures as the uncertainty. Okay, now that's given in the so that's given here in the manual, all right? But for now, you're not going to need that. You're only going to need the measurement values. So let's suppose you're using the Vernier caliper, and as it says here, you are measuring longitude that is 7 point, and the 0 in the Vernier scale lies between the first and the second division. So it's between 7.1 and 7.2 centimeters. We're using a centimeter Vernier scale. So how do you find whether it is 7.15, 7.12, or etc.? Basically, you have to look at the Vernier scale, and you have to look at which line in the Vernier scale aligns perfectly with a line in the main scale. So here is the third line. So 7.123, so 7.13 centimeters between 7.1 and 7.2. All right. So that's how you read a Vernier caliper. And that's what I did, because again, you guys are doing this online, so most of you are not going to have access to a Vernier. So I'm giving you the values in here, so you can use them to calculate again the average of the length, the width, and the height. Using the inside calipers, if you think about it, or if you take a look at this, you have the outside calipers and you have the insides. So you can use the insides to measure the inside diameter and the outer diameters of a cylinder, right? So I did that, and I measured these inside diameters. And then I also measured the inside depth of basically of a can, a cylindrical can. Now, what's the zero correction? Let's suppose you close your Vernier. So let's suppose you bring the outside calipers here. The zero scale has to be aligned with the 0 in the caliper. If that's not the case, then you have to make a correction. The caliper I used didn't have that issue. Normally, calipers don't have those issues. So then my zero correction is 0. All right. Then I use a micrometer. Normally, a micrometer is a device that you use to measure diameters. You can place a sphere here or a piece of wire, right? And you can measure the diameter of the wire or the diameter of the sphere, like a ball bearing. So by using the spindle, by twisting it, you have the barrel and you have the thimble. The barrel gives you the main measurement in millimeters, and the thimble will give you the extra significant figure to have an accurate value of the measurement in millimeters. So I found the diameter, and I did have a zero correction here of negative 0.027. So I have to correct the diameter by using this and this. Basically, this minus this will give you the diameter corrected. And you can find the average of the zero correction, the uncorrected, and the corrected. All right. I did the same for the thickness of a glass plate. Think about a glass plate. So it's very difficult to do that with a ruler or even with a Vernier. However, a micrometer is actually very useful for this type of measurements. So that's what I did. And then using the same micrometer, I measured the thickness of a glass plate. So make sure you write down here the corrected values. And then I also measure the thickness of a hair using the Vernier caliper and the micrometer. And as you can see, the Vernier caliper or the micrometer, sorry, is more accurate than the, or is a little bit more accurate than the, by one significant figure than a Vernier. All right. And then you are going to be measuring masses using a beam balance mass and using a digital scale. So obviously the digital scale is more accurate, more precise. And the triple beam balance, well, it's only accurate up to one decimal place, as you will expect. Look at the difference between the masses of a same object using the digital and the beam balance mass scale. And then here is what you have to do. You have to use the data from tables 1 and 2, and you're going to calculate the volume of the block. So how are you going to do that? The way you're going to do that is by being very careful with the values you're going to write down. So here is the values of, yeah, this is with a ruler, right? So I'm going to use the average, or you guys are going to use the average. However, let's suppose I'm using the first observation. All right. So if I want to find the volume, you know, it's equal to length times height times width. Now, my length is 7.6 centimeters. My width is 3.8 centimeters. And my height is 7.5. So I'm just going to multiply this. Now, be careful, because your units are going to be in centimeters cubed, right? So the volume will be 7.6 times 3.8 times 7.5 centimeters cubed. Okay? And that's how you get the volume using the ruler. If you use the Vernier caliper, you have to use the data from the data from table 2. They will have an extra stick feet. So be careful when you do that. You will have two different results. A bit close one another, but different. Then it says, using the volume as measured with the Vernier caliper as the accepted value. Okay, how do you find the percentage difference between two values? Okay. So to find the percent difference, let's suppose the accepted value. So if the experimental was 40.5 centimeter cubed, let's suppose, and the accepted value was of 40.17 centimeters cubed, then the percentage difference, actually, this should have two sig figs. It should have 3. So 40.2, and let's make this 41. Okay. The absolute value of the difference divided by the accepted times 100%. All right? So that's what you need to do for the second question. Third question, using the data in table 3, find the inside volume. How do you find the volume of a cylindrical cap? So to find the volume of a cylinder, what you need to do is you're going to multiply the area of the base times half. Now, in table 3, you are measuring the diameter. The diameter divided by 2, that's the radius. So that's how you find this. And the height you're given. So one thing that I forgot to mention, and you're going to be covering this in the lecture, is when you propagate significant figures. If, for example, you're multiplying 3.2, which has 2 sig figs, times 2.16, the value, the answer should have 2 sig figs. You have 3 sig figs, 2 sig figs. So the value here, if I were to use a calculator, uh, 3.2 times 2.16, I get 6.912. So 6.9. That would be the answer. So that's what you have to do here. I don't want to see answers in your lab reports where you have several suffixes. You will lose marks. Okay, you will lose points for that. So be careful. So question 3 is about finding the volume of the cap. And question 4 is about finding the volume of the sphere. Question 4. The volume of the sphere is the volume of the sphere. So the volume of the sphere is equal to 4/3 pi r cubed. All right, so if you have the diameter, you divide by 2 and that will be your radius. Now, let's suppose your diameter was 1.508, right? The radius will be that divided by 2. You keep the same number of decimal places, by the way. 0.754. So you reduce, put that in there, and then you multiply. 3 significant figures. So the final answer should have 3 significant figures. All right? Okay. And then you have to answer the last 2 questions at the end of the lab. So here it is, questions 1, 2, 3, 4, 5, and then the last 2 questions, where you have to explain why a perfect measurement is not possible and discuss the relative merits of each instrument. Since you're not using the instrument, you just want to discuss based on your results. All right? Now, if you're interested in the instruments, the lab will be open here at the Cranford campus every day, especially in the morning and in the afternoon up until 4 or 5 p.m. So if you are interested in taking a look what we do in the lab in person, you're welcome to come, all right? Remember that I gave you have to upload the syllabus, but you can find my information in here. All right. So that's my email. If you have any questions, all right. Remember that there are no meetings, but I can do some office hours here and there. All right. And I will let you guys know when that will happen. Okay. So that's the first lab. I will create another module here with the videos I'm going to start uploading today, actually. A week before we start with the course, so that will give me time for a couple of videos. The second lab is about statistics and error analysis. So it's similar to the lab we just discussed today. In here, it's shorter actually. In here, you're going to be looking at the difference between the British measurements and the metric measurements. So you're going to be given 6 random measurements of the length of a block in inches and in centimeters. You're going to find the total, the average for both, the length and the deviation in meters and now, this deviation is different to what we had before. When you have the 6 measurements here, maybe I should open the data. Here I give you all the length. You're going to find the sum of all those values and then the average. You're going to find the difference between each value and the average, and you're going to write it here. It can be a negative deviation or a positive deviation. So be aware with that. That's part 1. Then part 2 is asking you, calculate a conversion factor for a number of centimeters per inch. Okay, so that will be by using, for example, this length. You can find the factor between centimeters and inches. Show your calculation. And then you're given here the theoretical factor. You have to do a % difference like I just showed you from lab 1. All right. And then you just have to answer these 2 questions. So the second lab is actually not so bad. The second lab is more about an introduction on how you're going to be performing measurements. Most of your measurements, if not all, are going to be measured in the SI unit system. But this lab will show you the difference between the British system and the metric system, which again, you're going to discuss a little bit in the lecture. That's chapter 1. Okay. So the first 2 labs have to do with your chapter 1 topics. And as you can see, the first 2 labs do not need you to download any software yet. You should have it, but you're not going to use it yet. In the next video, we are going to be covering the first lab where you're going to need to use your exploration of physics. And I'm going to go over that program right now, but in the next video, I'm going to show you again how to get access to it. If you have a Windows computer, okay, so I'm just going to show you how to install it here. The file is here. So I will use this. All right. So pretty much, just put yes. Yep. This tool will allow you to simulate quite a few of the experiments that you will do in a lab. So let me show you how this program looks like. When you open it, you will have your subsections for each branch of physics that you can do in here. Motion is the main or probably the only one that you're going to use in this course. you will be using the force table in lab number 3. Okay, so I don't want to go ahead too much in this video with this, but in chapter 3 in chapter 3 in the lecture, you will be covering everything related to vectors. And it's very important that you understand what a vector is, what a scalar is, and what tools and what measurements you can actually study by using vectors. For example, velocity, displacement, acceleration, right? But you also want to know what the X and Y Cartesian plane is and how we can use it to explore vectors. So once you do that in the lecture, then you want to watch the second video in this Canvas site, in this for the lab, where I'm gonna be going over this. All right, so that's basically exploration of physics. If you have a Mac, there is the Mac file here. Now, I know that some of you may have issues because of the version of the iOS system you have. If you have issues, please let me know so I can arrange a group for you guys. As I said, the labs are done in groups, but some of you want to do it individually. So that's fine with me. But if you don't have access to the program, you may actually want to work with people where you can actually meet online or in person, and then you can actually have access to the simulation and gather your data. All right? So lab 1, lab 2, what do you need to upload as submissions for your files? So if you go to assignments, you need to upload 2 files per lab. You're gonna upload the group report and the theory and method. If you are doing the lab individually, this will just be your own file. You don't have to worry if it says groups in there. All right? I will be arranging the groups sometime this weekend before Labor Day. All right? Once that's done, you will receive an email, and then you guys can start having access and start trying to talk to one another. All right? If you find difficulties for this, please go to discussions, where I will create discussions for each lab so we can actually have more interaction between us and you guys between this course. All right? If you want to meet me in person, I'm normally here on Cranford at the physics department or in the science building every Tuesday and Thursday between, well, Tuesdays I'll be here, I'll be in the science department between 4 or 5 till like 7. And then on Thursdays, that will be a bit more complicated, but you can meet me at the observatory. Right now, that's where I am. There is an observatory on Cranford, in the Cranford campus, where you can meet me. I'll be teaching a lecture in astronomy, but you can come and we can talk a little bit if you have any questions, or we can do it via WebEx or Zoom. All right? So that's it, guys. I will close this video now. And if you have any questions, please feel free to email me anytime this semester. Have a nice day.